Alright, starting with the first one. It has an average growth rate of 2%. The formula for your growth is A equals P sub 0 times 1.02 to the T power. PO is the original population and T is the time in hours. So down here, you begin with 200 bacteria. Well, that's the P sub 0. And how many bacteria will there be after 100 hours? Well, that's your T. So all I'm going to do is I'm going to use my calculator. I'm going to plug in a 200 times a 1.02 to the 100th power. I get 1448. So that means that the answer that's closest to this is C. Alright, moving on. Which one represents the sequence? Well, the sequence would be 6, 18, 54, 162. Clearly I'm starting with a 6, I'm multiplying by 3. So that means if I'm multiplying by 3, can't be this or this. I need a base of 3. So it's one of these two. I can pretty clearly see that it's going to be this function right here, but if I couldn't see it, it would be really smart for me to plug this into my calculator and to let it show me that literally it makes these points. Okay. Again, a calculator would be extremely beneficial for me. Even if I don't, I can actually take any of these points. I'll say 225. Is 2 to the second power 25? No. 3 to the second power? No. 4 squared? 5 squared. 5 squared is 25. So clearly this is. But I could also use my calculator. Which function shows this translated 5 left? Well, left is going to be when it's with x, so it's not A, it's not D. Okay. Left 5 is actually this one. Okay. X plus 5 is your exponent. Down 5, okay, A. Alright, consider this pattern. Well, as soon as I hear pattern, I'm going to start to notice. There's 1 here, 4 here, 1, 2, 3, 4, 1, 2, 3, 4, 16 here, okay. So, see, 4 to the n minus 1 power. If I plug that in, I would get this. So, again, using a calculator in the table, I would be able to see that the first term would be 1, second term 4, so on. Alright, number 7. Here's a exponential decay, it looks like, relating the height of the ball to the number of bounces. On which bounce was the height of the ball 10 feet? Well, that's pretty simple. I go to the height of the ball, which is 10, find a point. This is at 1, so it is bounce 1. Okay, look at the graph. Which equation represents this graph? Well, I can automatically see that this is at 2. Because here's 1, there's 2. So I automatically know that it is added 2. So, boom, B. If I didn't know any of that, I'd use my graphing calculator and I would look this thing up. Look and see if it matches.